So hi everyone, so welcome back to the second part of this video, that is performance evaluation metrics of image encryption methods and its implementation using Matlab. So in the previous video we have seen the histogram and its implementation using Matlab, and information entropy and its implementation using Matlab, and in this video we will be seeing the correlation coefficient, and in the next part we will see about the NPCR and USCI. Correlation coefficient. The correlation coefficient is calculated by using this equation, that is correlation of x between x comma y is equal to covariance of x comma y and square root of d of x into square root of d of y. So here gamma of x comma y is the correlation coefficient, and covariance of x comma y, COV of x comma y, is the covariance of x and y, and we can calculate the covariance between x and y by using this formula, that is covariance of x comma y is equal to 1 divided by n into summation of I is equal to 1 to n xi minus e of x into yi minus e of y, and we can calculate both e of x and e of y by using this formula, that is e of x is equal to 1 by n into summation of I equal to 1 to n xi, and similarly e of y is equal to 1 divided by n into summation of I is equal to 1 to n into yi, and subsequently we can calculate both d of x and d of y, like d of x is equal to 1 divided by n into summation of I equal to 1 to n xi minus e of x power 2, and similarly we can calculate d of y is equal to 1 by n into summation of I equal to 1 to n yi minus e of y power 2. So here n is the total number of pixel pairs xi comma yi, and e of x and e of y and d of x and d of y are the mean and standard deviation of the pixel values xi and yi respectively. And the built-in provision or function supported by Matlab to calculate the correlation coefficient is r is equal to COORR2 a comma b. So here a comma b are the two-dimensional inputs, that is we are going to calculate the correlation between a and b, and r will be the result returned. Okay, so this CORR2 returns the 2D correlation coefficient value, which is r, between the two arrays a and b. And if you consider any image like this, and if you extract a small part like maybe 6 cross 6, and maybe you have the corresponding gray levels here, and when you compute the correlation between the original and the encrypted image, let's take if this is the original gray level value, and the correlation between this original and encrypted should be very low, and in some cases we calculate the correlation between the adjacent pixels also. So here if you take this correlation between 170 and 238, yeah, some correlation is available. This is called maybe a horizontal correlation, and maybe correlation between 170 and 136 may be called as a diagonal correlation, and correlation between 170 and 68 is called vertical correlation. So typically in a original image the correlation between adjacent pixels will be high, but in the encrypted image this correlation between the adjacent pixels will be very low. So let us calculate this code or using Matlab. So this will be the code to calculate the correlation between the original and encrypted images. So first we need to read the input image using imread, that is original, and next we need to read the encrypted image, and in some cases we may need to convert the color images into grayscale images. Typically color images will be in 3-dimensional, but these functions will accept 2-dimensional as an array, so we need to convert RGB to gray, and in some cases you can resize. So maybe the given input image may be resized into 250 cross 250. Similarly the encrypted image is also converted into a grayscale image and resized into 250 cross 250, since both I and C should be in the same dimension. So while calculating the correlation coefficient, so CORR is equal to correlation coefficient of I comma C, and you can display the value of the result. So let me run this code first. So correlation So enter the input image, so original dot bmp, and enter the encrypted image, encrypted dot bmp. So you can see here we got this value, like 240, 230, 23. So the original image is in 3-dimensional with 240 cross 230, so that we resized into 250 cross 250. And similarly the encrypted image is also of dimension like 248 into 256, 3-dimensional. So that is again converted into grayscale using RGB to gray and resized into 250 cross 250. And you can see here the correlation between the original image and encrypted image is 0.0064, which is very close to 0, meaning that the correlation, there is no correlation between the original and encrypted images. So it's a good result. And coming to the adjacent pixel correlation, so for while calculating the adjacent pixel correlation, so we need to again read the input image, and we need to read the encrypted image, and we need to resize if needed using the IM resize method. If both input and encrypted images are resized into 250 cross 250. And while calculating the adjacent pixel correlation, we need to choose some randomly, we need to choose some amount of pixels. Here we have chosen 8000 pixels, meaning is that let's take, even in this image we have maybe 6 cross 6 matrix. In real time we have chosen 250 cross 250, so we choose randomly. Maybe if I choose 136, so correlation between 136 comma 70, and correlation between 136 comma 0, and correlation between 136 comma 238 will be calculated. Similarly, randomly if I choose the pixel value 85, then the correlation between 85 and 170 horizontal, correlation between 85 and 68 diagonal, and correlation between 85 and 221 is vertical. So like that the adjacent pixel correlation values is also calculated. So let me run this code. Adjacent pixel correlation, so original dot bmp, and enter the encrypted image, so encrypted dot bmp. So while executing this code, for the horizontal correlation for the input image is 0.9, which is close to 1, and for encrypted image is 0.3, so it's acceptable. But anyway, if it is again 0.1 or 0.00 something, it's better result. And for vertical, original image it is 0.97, but for encrypted image we got 0.3234. So again it is acceptable, but when you get any value close to 0, it gives better result. And for diagonal correlation, we got for the original image it is 0.9695, which is again close to 1, that is high correlation, typically acceptable. And for diagonal we got 0.094. Yeah, so the diagonal correlation is very low in this case. So so this will be the best result. Even it is 0.00 something, means it's good. So in this way we can calculate the histogram, entropy, and correlation between the original and encrypted images, and correlation between the adjacent pixels of the images, both in original and encrypted. Okay, thank you, thanks for watching the video.